Everyone. My name is Leilu, and I'm a Tableau and Alteryx consultant at the Information Lab US. Thank you so much for supporting and giving me the feedback from the Reverse Data Dev Challenge. Um, so I'm coming back here today to share the solution for the newest challenge from Data Dev Quest. There are two challenges with two level, beginner and intermediate. And those challenges are rated by Nick Dutra. He's a Tableau Data Dev ambassador. I know that Nick is from Brazil. Um, Nice to meet Nick at Tableau Conference 2025. Um, and so excited to work on this challenge that met by Nick. Um, so in this challenge, there are two levels. So I will start from beginner challenge and also explain what is the problem for each level. Um, I also post this on the solution on my GitHub that I share in the link that you can clone this prep into your computer and running it. In the README files, I also explains and sharing the screenshot of the output that I got by running the Python script. At the end, I also show the instruction how to run this program. Okay, let me go back to the challenge. But before going back to the challenge, you can connect with Nick on LinkedIn. This is his profile. Okay, so this is the challenge for beginner for the last month. So we would like to convert the Excels and the data frames into the Tableau hyperfiles. As you know, to publish the data source on Tableau Cloud or server, it should be in the hyperfile. And this challenge would be really helpful when you working in Python or you are doing with automate workflow. So whenever you extract the data from the API or do web scraping from somewhere, and then you would like to publish those data source into Tableau Cloud or server, this challenge is really helpful. Um, to help you write the data frame into the hyperfile and then publish them into cloud server. Uh, for the beginner challenge, the learning goal here that after doing this challenge, you are able to read the Excel data into using pandas, convert the data into Tableau hyperfile format into methods. That is PanTab and Tableau Hyper API that I will um, uh, explore with you in a few more seconds. Um, and get started, you need to install Python. Should be 3.6 version or newer. And you also need to install Pandas, PanTab, and Tableau Hyper API to work on this challenge. Below it the instruction how to set up the environment to run and work on this challenge. For the solution expectation, that you can able to turn your Excel data into hyperfiles by using two methods, PanTab and Tableau Hyper API. You also need to record the running time of those two methods and then compare which methods running faster um, by working with the similar Excel file, um, and should also handle different data type. Like in one data set, it could have the date data type, the text or number. So we need to handle all different data types and testing your solution on the Tableau desktop. connect to that hyperfile that you just wrote by using Pantap and Tableau Hyper API, and make sure that all your data um, is crossed safely, and all the data types that is understandable. Like the day should be days, not the text or the numbers. Number should be numbers. Working in the Python script, let's explore what is Pantap and what is Tableau Hyper API. So for Pantap, if you search on Google or go to this link, pantap.grid, the docs.io, you will go to the documentation of Pantap. So Pantap is a fast and easy way to exchange the data between Tableau Hyper format and also the data frame like pandas, polars, or pi arrows. To install Pantap, just type uh, pip install Pantap like this. Um, and below you can see some example of how to write a Pantap and how to write via Hyper API. For Tableau Hyper API, that is an API from Tableau that you can use to read and write the Excel file like CSV, Excel, or the data frame into Hyperfile. And you can also use Tableau Hyper API to publish your Hyperfile into Tableau Cloud Server. Um, so go to tableau.github.io/hyper db and splash docs. It will link you to this documentation. Okay. In Pantap, if you click on usage example, there are many examples right here for you to explore. For example, in the beginner challenge, we need to write to a hyper extract. So click on that, and then you will see to write data frame like this, pandas data frame. We need to use the frame to hyper function. In Tableau Hyper API, you click on guides and then use or create and update hyperfiles. So you need to create a hyperfile. Just follow these scripts. Um, I will explore more in the Python script. As you can see, it's easier to write a hyperfile by using Pantap because you only need to use this function. But in Tableau Hyper API, you have to write the script to write a hyperfile. Okay, let me open the Python script. So in this Python script, at the beginning, I need to import on the package that I need to use for this challenge. So I need pandas for the data frame, time to record, the running time, Pantap, and Tableau Hyper API to help me read and write Hyper5. Um, for the config, this is the parent path that I set, where I save on the hyperfile and also my input data. Um, moving next, I have a function called fry hyper by Pantap with the argument is data frame df. Output Pantap, that is the location where I save the hyperfile after I write by Pantap. As I mentioned at the beginning, I only need to use a frame to hyper and then passing the data frame with the output Pantap. And then I put a name for the table. For example, right here, I put the table name, that's the order list, because I know that the Excel file that is it has a sheet name called order list and process params. Uh, This is so this is optional, so you can set the default database version is 3. It means in Tableau desktop, um, the default database version 3 means supporting storing and querying 128-bit number, and it can be supported in Tableau Desktop 2020.4 and for the server of 2023 or newer. Um, so in the documentation, you can set it to 2, 3, or 4. Um, and if you need, you can go to this documentation to read more about this default database version. And then after I write to a hyperfile, I want to show on the screen how many rows were written by using PanTab and the location where it's located in my computer. Um, so I bring up this out on the screen. To write a hyperfile by using Hyper API, also pass two arguments. One is data frame and the other one is the path to the database. I use try and accept here to catch the error if it happens. And to start write a hyperfile by using Tableau Hyper API, I need to define the table by using the table definition function. And then I store it into extract table. So in this table definition, it has two parameters. The first one is the table name. Like you have to set the schema name and also the table name. For the schema name, I put extract. I know Tableau like the schema name with the extract, and for table name, I put it as the same name in the sheet name. So it should be so I put all the lists. Um, and the other parameters that is the columns. So I have an array of column here that is all the columns that I would like to set in the hyperfile. So I assign each column with the SQL type, for example, order ID. That's in double because I know there's a dot or something in there, so put double. For order date, the SQL type should be a date, so it cannot be a string. Um, and for the order, it could be integers or the var character or double. Um, but I see this one is okay if there's a few columns. But if a data set there are many columns, like 20 or more than 30 columns, we cannot do type manually. It lies like this. So in the bonus challenge for the beginner, I will have another function to help you um, assign the data type for each column dynamically. Okay, after that, after I define the tables, I use rows to insert to iterate into each row in the data frame. So it will help me to insert the data later by using the inserter function. Um, so I use data frame df dot iter tuples with no index and no name. Get to write to a hyperfile in Tableau Hyper API. We need to set the hyper process. Um, so according to the documentation, I use the hyper process class with telemetry, send the users to data to Tableau, and with this parameter that I just explained above. Um, so hyper process, let me open. the documentation. So hyperprocess does allow you to connect to the server locally on your machine. Um, um, and then it will bring the connection with the endpoint. And this connection string describe that how you use the protocol like TCP domain socket or like the port numbers and the connection class that we will use later. It will help you to connect again this endpoint. Um, and when the hyper process is running, you can create and connect to many .hyper files you want. Okay, let's go back to the script. So I have the hyper process here with the width. So if you define the hyper process class with the width, you don't have to close the connection because it will automatically close it for you. Same as the connection here. In the connection, I set up the endpoint that is hyper endpoint, as I would like to output the hyperfile. The database, this is the path that where you want to store the hyperfile. So I set it to path to database, which is the argument that I pass into this function. For create mode, so there are many create mode that you can read in the documentation from Tableau Hyper API. In this case, I would like to create a new hyperfile. So I use create mode, that's it, create and replace. Well, it means if it uh new, there's no schema or the table before, it will help me to create a new one. If it exists already, it will be replaced. And I store it as all of this as a connection to create the schema first. So we need to call the connection dot catalog dot create schema with the parameter inside that is schema equal extract table dot table name dot schema name. Um, so extract table, that is the table that we define at the top with the table name. That is the table name or the list, and the schema name is mean extract. Um, to create the table from the table then definition above, we use the function called create table with table definition equal extract table, which is here. And now after we got the schema and the table, we need to insert the data into that table with that schema. So I use the inserter class with the parameters such as connection and your extract table. So just use the add row function with the rows that equal to rows to insert, which is this one. Um, and then execute. So after you execute, it will input on the data in the data frame DF into this hyperfile. And then after I did all this, I I use query call connection execute Scala query um, to bring out the result for me. Um, so it will execute this query, select how many rows from this table. And then after I got the result, I bring out the string, how many rows that I inserted already, and where's the file is located. And this is catch the hyper with the hyper exception to catch the error. Uh, for this function, check sheet exists in the file. So if the sheet name that I specify that exists in the Excel file, if it exists, it will go to the next step. If not, it will show the errors that that sheet name doesn't exist in Excel file. So we know how to check the Excel file before going to the next step. And here's the main function. So this is the Excel file path that is stored in the parent path. This checks if the path exists. Also check with that sheet name, and then I read the Excel file and then store it into pandas data frame df. So I set the output pantap here. This is the location where I save the hyper file after writing by pantap. Um, and then also check if that directory exists. So I use the time function to record the running time and store it into start time by pantap, and then call the function write hyper by pantap, and then pass data frame df and output pantap, ending the time by calling the time again, and then I will get the elapsed time by pantap by using end time minus the start time and get that in the seconds. Uh, for the Hyper API section, I also set the path to database. This is the location where I save the Hyper file after writing by Tableau Hyper API. Check if this path exists. Then start record, call this function, write Hyper by Hyper API, and the running time, calculate the elapsed time. And then from here, I will compare the elapsed time by using Hyper API and the elapsed time by using Pantap. Okay, cool. Let's run it. Let's run the program from the terminal. I will go to the beginner folder, Python. Yeah, after a few seconds, I got the result. That's elapsed time by Pantap is 1.4 seconds. And elapsed time for Hyper API, that's 0.59 seconds. And the difference is 0.8 seconds, so it's not much. That is for the beginner solution. But we also have the extension and so bonus challenge. Now we need to handle multiple sheets um, and create a command line tool, add error handling, and optimize the really big data sets. Also add an option to update the existing hyperfile instead of starting from scratch. So I didn't do two of these, but I did for three of these um, op options. Um, to optimize for the really big data sets, I think when we have a big data set, like you have a big piece of pipe. It's really big, and to make it run faster, I think we can split it into small pieces. So in this case, if we have a big data set, we can divide it into small chunks, or we can um, write the data into a hyperfile by using the timestamp. For example, when you extract the data, you assign a timestamp when you extract it on the date or time, and then when you write those data into the hyperfile, you can um, use filter. For example, I would like to write the data day by date or by hour. Um, it could be helpful to optimize a really big data set. Um, for this option, I think I need to work more on this. I need to check if the schema exists already. If it exists, I will ask the user, do you would like to append the data into that exist schema and the table name, or would you like to create a new schema name and the table name? So that's there are more options for the user they can do. Um, but yeah, there are more work. So I will work on that in a separate program. But in this case, I only work on three this. I'll open the script for that bonus challenge. Um, so in this bonus challenge, so I import all the package are the same, uh, and there are some differences in uh, the function. So to write multiple sheet uh, to a hyperfile by using PanTab, I need a sheet dictionary and output PanTab. So for sheet dictionary, it means I will store the data frame in the dictionary. As you know, in the Python dictionary, we will have the key and the values. It's like the JSON file. Um, so I will store each sheet like one key with the values. Um, and when I run the function, when I only call frame to hyper, it only output me for the last sheet. It means it um, replace the uh, current sheet by a new one. So to handle that, I need to get the index for each data frame in the dictionary. So for the first data frame, I would like to write it by set the mod, that's e write W. But for from the second sheet and more later, I need to use the append mode. This means I will append a new sheet into the hyperfile. So will set uh, if the first index, this will be right. But if it's not the first index, I will append to the hyperfile. And I also use the same function frame to hyper. But in this case, I will set table mode. That's equal mode here. And also bring out how many rows after the data were written by using PanTab and where it's located. As you remember from the beginner solution, when we define the table, we need to type on the column like this. Uh, but like I say, if we have more than 30 columns, we cannot do manually like this. So I use a function. It's called convert to SQL type. As you know that we are using the pandas data frame, and in pandas there's a way that help you to check is that the data type like integers, double days, or a string, and then it will help me to convert it to the SQL type. For example, right here, if the column, I will pass the column to here. If this column is integer, I will change the data type to SQL type int. If it's a float, I will convert to double. If it's a datetime, I'll convert to the date. Otherwise, everything would be in the text. Okay, moving next to write multi-sheets to Hyperfile by using Tableau Hyper API. So the same arguments like PanTab, I will pass the sheet dictionary path to the database. Okay, I will set the same hyper process connection. Uh, Schema name, that's the extract. In this case, I use the for loop to loop into each sheet in um, the sheet dictionaries. So into each item, and then I will define the table by using table definition class. Um, so the table name, which is the sheet name in the Excel file. For example, the sheet names is order list. It will put the order list for this table. And for the columns array, instead of typing all of this, I will only need to call one script like table definition column with the name equal column, um, uh, column and the type equal this function, and then I pass the column name from df into here for all the columns in the list of the columns here. So it means it will iterate to each column into data frame and then convert the data type of each column to the SQL type. For create the table, so we create the schema already here. So we should put that in here, not in here, because if you put the create schema name in here, it will get an error like this schema name already exists in the hyperfile. Um, so I put the schema name over there. So every time it loop in the for loop, it will create a new table and use the same schema name. Rows to insert, that is from the data frame df. That we loop in the dictionary. And to add the rows, we use the inserter class, same as we did in the first challenge before. And also I'll put the how many rows and where it's located. Same function to check the sys is this in the file. In the main function, I do the same thing. Nothing much change in this case. Only change the function name in here and also with the path tab. Okay, let's run this challenge. Okay, it's run successfully. So you will see right here there 599 rows were written into the table order list by Pantap, and 28 rows were written to the table name called customer by Pantap, and elapsed time about 1.2 seconds. By using Tableau Hyper API, got the same result. 599 rows were inserted into this table order list. 28 rows were inserted in the customer table. Elapsed time for Tableau Hyper API, that's 0.5 seconds. So the winner is Tableau Hyper API. Um, with the difference is 0.6 seconds, not much. But I think for this test, we have only 599 rows. I wonder if we have more rows, like more than 10,000 rows, or 100,000 rows, or million rows, this result could be different. Okay, that is all the challenge for beginner. Let's move to the next challenge in intermediate. Um, for intermediate, we will have two tables. This means two separate Excel file, and then uh, we need to write two Excel file into one hyper file by using Pantap and Tableau Hyper API. Um, oh, before that, I need to check in Tableau Desktop. So after I run successfully in the terminal, let's check the result in Tableau Desktop. Click on More, and then choose the output for Pantap output in here. So this is the beginner one, only one sheet. As you can see, the public is mean writing by Pantap by default. The schema name would be public. Okay, order ID, that's a number, order date. This in date. Uh, okay, origin for text. Okay, weight, number, unit, quantity. So all the data type is correct. Let's input the Tableau Hyper API, Hyperfile, but using Tableau Hyper API. Okay, let I this first. So after I import, you will see order list. But the schema name now is a extract dot order list. Means because you remember that we set the schema name that's the extract. Um, so all the data types also match with the result that we have in Pantap. So number for order ID. This is date for order date. Okay, weight. This should be in number. Unit quantity is number. So everything all good. We'll add the multi-sheet one. So this is a multi-sheet by using Pantap. So you see we have two table, customer and order list. With the schema names is in public. Let's check the customer first. So customer have customer name. That in text, product ID, plan code text, destination port. That's in text. That's right. Check order list. Okay. Order list, order ID, number, order date in date, and weight in number, unit quantity in number. That's all correct. Now we check the Tableau file for multi-sheet by using Tableau Hyper API. Customer using, so you see the extract here, that's a schema name were written by Tableau Hyper API. Product ID, number, all other text, right? Let's check all the lists. Okay. The order ID, number, order dates, and in date, weight, that in number, unit, quantity in number. Okay, everything is correct. Okay, that is how you can check that you are doing correct. Uh, let's move to the intermediate challenge. In this intermediate challenge, you will write two separate Excel file into one hyper file. So in the bonus challenge in the beginner that we did, writing multiple sheet into one hyper file, and this one looks similar. The difference is that's multiple sheet in one file, but this one there are two separate Excel file with the sheet, and we would like to write into one hyperfile. Um, so this get started. How to set up environment, solution, expectation. So we need create hyperfiles contain both table using both methods in Pantap and Tableau Hyperfile, Tableau Hyper API, and then need to run the SQL queries against both table and save the filter result. Um, for the filter result, um, let me move it back a little bit for the challenge. So we need to convert both Excel into single Tableau Hyperfile using two methods, Pantap and Tableau Hyper API. Um, run the SQLs against Hyperfile by using this filter. So for all the lists, we need to filter the weight should be all greater than 50. For the actual tables, we need the location with the latitude is less than 40, and then save on the query result. You need to create a Hyperfile first. That's in the first step by using two methods, PanTab and Tableau Hyper API. The second step is you need to read the Hyperfile from the Hyperfile that you just created by using two methods, and reading it by using the SQL queries, and you use that SQL query to filter the data like this condition. So after you read the Hyperfile, filter it, you will write that filter data back to the same Hyperfile. Uh, okay. So that's what we want in this intermediate. Um, I also did that. Let me open the code. So this is the intermediate solution. So I import on the library same as the beginner ones. Um, so the first step, we need to write the table, multi-tables into one Hyperfile. So I declare a function called write multi-tables to Hyper by using PyTab. I also use the dictionary table. You remember in um, the beginner solution, I use dictionary for the sheet. In this case, I use dictionary, but for the tables, it's the same. And also pass the output PanTab. Um, in the beginner solution, I use frame without s to Hyper. But in this case, we have multi-table, so we use another function called frames to Hyper, and then pass the dictionary table in with the output PanTab. Um, and then I also use the SQL query to see how many rows that I just throw into the Hyperfile, and then use another function called frame from hyperquery um, to uh, read the, to retrieve the data from this SQL query. So I put the output PanTab where I save that Hyperfile and then pass that query in here. And then I store it into a variable called order list rows, and then got the result. Same as this one. So after I wrote another table called actual into the Hyperfile, I would like to see how many rows uh, that's were written in this table by using SQL query here by using frame from hyper query and to execute this query too. So output where this Hyperfile is located. So you remember that we just wrote two tables into one Hyperfile, and now we need to read that Hyperfile and then filter it. So I use another function called read-write multi-tables by PanTab. In this case, I only need to pass the output PanTab because the data is in there already. We only need to read the file, read the data from that file. Um, so I declare this query one. I would like to see um, the weight is greater than 50 in the order list and get on the column. Okay, I use the function frame from hyperquery to retrieve the data from this SQL query, and then store it in the F1 and count how many rows in this data frame. I do also do the same for the actual table and filter the data by using the where clause in SQL with latitude is less than 40 and get all the columns. Do also the same by using frame from hyperquery and store it into data frame 2. Count how many rows. Then I store it back to a dictionary table because after we read two tables from the hyperfile, we need to store the result from the filter. So I need a dictionary table to store those results, the F1, the F2. And then I put a key value here is order list filter for the F1 and actual filter for the F2. And to write back to the same hyperfile. So the data would be dictionary table, and we need to store in the same file. So I use the same output pentap. So we read from output pentap and write it back also in output pentap, and it will also bring out where it's located. For Tableau Hyper API, so this is the convert to SQL type, and I declare a function called write multi-table to hyperfile by using Hyper API. Also pass the dictionary table path to database. Uh, Open the connection with hyperprocess connection here, create and replace. Create a new schema name, extract. Um, as you remember that we did in the beginner bonus challenge for multiple sheets. In here, I also do the same, but for table name, that's the name of the table, data frame in the dictionary table. So everything is looks similar like multi sheet, but in this case that in table, nothing new in here. So I go to the read multiples table from Hyper API. So to read the Hyper file from by using the Tableau Hyper API, I declare a function called read multi tables from Hyper by Hyper API and pass the path to database. Also open the connection with Hyperprocess and connection here. Note that here I didn't create and replace for the mode. I use none. This means I only want to read the data. I don't want to create and replace a new schema or table. Um, so create mode would be none. And I declare the queries. So you know we have two different tables and we need to filter the data for each table. So I use queries. Um, that's in the dictionary. Uh, the first key values that's the order list. So I filter the data with the weight is greater than 50 and latitudes less than 40 for the actual tables. Um, and one important thing that I noticed here that you should put the schema name and with the table name in the pen tab. You don't have to put the schema name with the table in the from clause, but in um, Tableau Hyper API, you should have the schema name and the table name together in the from clause. And everything should put in the double quotes. I declare I initialize a new dictionary called result dict, where I will save all the data after I filter. Same as the writing to Hyperfile by Tableau Hyper API, I use the for loop to iterate to each queries. As you see in query here, that's a dictionary with two keys for order list and also actual. And then I will loop into each queries to um, read the data and then store the data um, and then also add the columns. So execute query by each query in the queries there. And here I use also a for loop in the return scheme, return data. So this is return data from the connection with the schema and the columns. Because so for these column names, I need to clean the data in here too, because if I don't use strip the quotation and also um, pass the string into the column names, um, it will output the column name in this data frame with the double quotes and with the name outside. So I need to um, change the column name in string and then strip all the double quotes outside. After I got on the clean column names, put on the return data, uh, that's for execute. This means on the data after I filter the data here and then execute the query. I got all the data and store it in the list. For example, for this table order list, it will store all the data which has the weight greater than 50, store it in rows, and the result uh, that I initialized before. That is a dictionary with the table name in here. For example, the first table is order list. It will store all the rows and columns, which is the column names in the result um, dictionary. And do it the same for the order table for actual and do loop and the for loop here. One thing that I did during working on this challenge is it doesn't return correct data type for the date. So I need to check if the date is in the column. If it is this the order date, so it means if the date is in the column, I will convert the column name to data. I'm sorry, the column data type to data. And finally, I will turn the dictionary result dict here. So this one for checking the sheet is this in the file. For the man, everything is the same, but we have the sheet name here for this workbook, the actual from this workbook. Read two of these Excel file and then store it into two different data frames, the F1 and the F2. Set the output pen tab, and this is the dictionary table. So the F1 will be stored in the order list. The F2 would be stored in the actual keys. Um, okay, and here, whereas I record the time running by using pen tab. So I will need to call two functions. One is write multi-table to hyper pen tab. So it will write uh, two tables into one hyperfile, and then read and write the table. So I combine two steps in one function, read, write multi-table pen tab, and store in the same hyperfile. End the time, calculate the elapsed time by pen tab, output seconds. Do the same for Tableau Hyper API, but I use three function in Tableau Hyper API. First, I need to write multi-table to Hyper by using Hyper API. Next, I need to read the data from from the Hyper file. So I use read multi-table from Hyper API and store the result in the result variables. And then I pass the result, which is the dictionary, uh, back into write multi-tables uh, to Hyper API, which is the same function here. Um, so it will write this dictionary result into the Hyperfile with the same path. End time, calculate the elapsed time, and then output. Okay, let's run this um, challenge solution. Okay, I will change directory to intermediate Python. Okay, it's finished running. Did you see right here the 599 rows were written to order list and 499 rows written to actual tables. And then after filter, we have 104 rows from order list. 177 rows were written to actual tables. Elapsed time for this process by using PanTab, that is 3 seconds. How about Tableau Hyper API? Same result, 599 for order list, 499 for actuals. Then filter the data, 104 rows for order list, 177 for actual by Hyper API. Elapsed time is 1.4 seconds. So the winners is Tableau Hyper API again. Oh, and the difference time is almost 1.6 seconds. So um, Tableau Hyper API run faster than um, PanTab almost a half time. Okay, let's go back to the challenge. That is the intermediate solution, and here we also have the bonus challenge. So in the bonus challenge, we need to add a join or union query to combine data from both tables. Uh, so I guess because the columns name are different in both tables, so I think I can do with join. I also modify the Excel file to get the date match some from rows in the actual table that match with the order date in the order list, so I can use a join. Also, I need to implement aggregate queries by using count sum average by using SQL query against the data, and then create simple command line to allow the user to specify their all SQL filters. Um, so the in this case, we need to let the user to enter their or SQL query to retrieve the data, optimize the code. Um, so I didn't do two piece, but I think it's the same as I mentioned earlier from the beginning for very large data sets. So we need to split in the data set into small chunks and then write each chunk into the hyperfile by using the append mode. So at the first index, it should be right, and then for the second, it will be append. Um, yeah, I didn't do the last one. So I did three of these. Let's jump on that. Okay, I separate in a separate file. Um, so same import the library, write multi tables. Everything looks the same like intermediate. Um, read the SQL query by Pantap. Here's the different one. You join here, and I'll put three column. One column is location site name with aggregate is sum average. Um, so I have aggregation function here with one matrix location site name. So I need to group by location name, and if I sum up unit quantity, sum up weight, um, and join it by the order date from the order list with the date from the actual tables. Call frame from hyperquery to retrieve data from this query, and then store it into data frame DF. Bring the DF out of the screen because uh, they didn't say that we need to write back to the hyperfile. We only need to read the SQL query, so we'll bring it out the screen. Um, here the function that we can read the custom SQL query, so the user can input any query in here, and then I use the frame from hyperquery to read this SQL query and bring out the screen. For Tableau Hyper API, I declare so the write multi-table to Hyper API the same as the intermediate solution. To read the SQL query by Hyper API, so I pass the SQL query in here, execute the query, return the result. This one to help me to clean the data and store in the column names, rows. That is on the data from the result here. After retrieve the data from this query, I store it in the list, and then create a new pandas data frame DF with the rows of data here, the column names in here, and then finally return the DF. To read the custom SQL query Hyper API, I need to read the file. So open Hyperprocess connection, the same as the read query there. Execute the query by calling connection dot execute query. Clean the column names, store the data into rows, create a new data frame DF, and finally return it. Check the sheet exists function. Here everything is the same as the intermediate solution I saved. I showed earlier. Dictionary table for the list df1 actual, that is df2. Record the running time by using Pantap. Record the running time by using Tableau Hyper API. Compare the results. And here's the program that I let the user to enter their OR SQL query. So I let the user to input the option they want. So there are three options. Um, the first option is they would like to test the SQL query with Pantap. They will press 1, enter. If they would like to test with Tableau Hyper API, they will choose option 2. And if they would like to exit the program without testing anything, they will choose option 3. For option 1, I will call the function read custom SQL query by Pantap with the input query in here. Option 2, call the function read custom SQL query Hyper API here. Bring the result. For option 3, access program. So they would like to access the program. So access program would be becomes true before it be false. When it becomes true, it will exit the program. And if they choose any option not in 1, 2, 3, it will put the error here. And after that, it would like to test, like choose another option. They can choose the yes or no. to continue. Okay, let's try that. Python frame. At the beginning, 599 rows were written. 499 rows were written into actual tables. For Pantap, it's only return 2 rows. After I custom the SQL query with the join and add the sum and average. Elapsed time is 1.5 seconds. For Tableau Hyper API, so it's write the same number of rows to all the lists and actuals. But for reading the Hyperfile from my custom SQL, it return 9 rows. Uh, I don't know why, but for the elapsed time, it's return 0.9 seconds. And Tableau Hyper API is still the winner. Let's test the SQL query. So if I choose by Pantap, choose one, select, I would like to count how many rows from actions. There are 499 rows, so that's correct. I would like to test another SQL query in, yes, test Tableau Hyper API. Select from, oh, I need to put the schema name in here, order list. Return 599 rows in order list. Okay, I don't want to test anymore. I press no. Okay, that is all the solution for the intermediate. Oh, I need to check in Tableau Desktop if the data type is correct. So my Tableau Desktop here, let me remove this. Multi-tables output. So this is from multi-tables output by using Pantap. That's actuals. Okay, everything is right. Oh, because I tried to the same 5 again in the intermediate solution for the bonus challenge. So it's not a filter here. But if I run again the program in intermediate solution, it will show me the filter here. So everything was correct. Let me run the uh, intermediate solution, which has the filter again. So from here, you will see the number of rows is 104 for all the list, and actual is only 177 rows. Open Tableau. And tap multi tables. Okay, from here you see the actual filters. Only 177 rows. So in this case, we filter the latitude to less than 40. So I choose the sorting here in descending. So the highest one is 30, 9.95. So that's right. All the data types correct for all the lists. 104 rows uh, with the weight uh, with the weight is greater than 50. So I changed the sorting by ascending. So the smallest number here is 50.68. And it agrees here. So I think it's right. 104 rows. On data type is right. Let's try adding Hyperfile by using Tableau Hyper API. Okay, let me remove this. Oh, sorry. For actuals, 177 rows, right? Latitude. So sorting in descending, the largest number is 39.95, right? On data type is correct on the list. Weight is greater than 50. That's right. On data type is correct. All the data is in date. Okay, on solution. For that is on the solution for intermediate. Let me go back. This is on the solution for beginner and intermediate challenges from Data Dev Quest Challenge 2025-05. I hope you also learn a lot from this challenge, same as me, as I learned a lot from this challenge. So I know how to convert the Excel file data frame into a Hyperfile, how to write a single sheet, multiple sheet, multi tables into one Hyperfile, and how to use the SQL query to filter the data and write back to a Hyperfile. And also I can use a custom SQL query to retrieve the data I want from the Hyperfile. Um, yeah, I hope you enjoy it. And if you have any question or any feedback to me from this solution, um, please feel uh, please feel free to comment it in the comment in YouTube channel or also in my LinkedIn post. Yeah, thank you so much, and see you in the next challenge.